Hi there, we've got a GCSE chemistry past paper question on atomic structure in this video. It goes on to explore ideas of the development of the periodic table, electron configuration, and how electron configuration is related to reactivity. Let's take a look. So 4.1 asks, what order did scientists use to arrange elements in the early periodic tables? And 4.2, in the early periodic tables, some elements were placed in the wrong groups. Mendeleev overcame this in his periodic table. Give one way Mendeleev did this. So 4.1, first of all, we have to remember that in the beginning we didn't know about electrons and protons or neutrons, the subatomic particles. So before we knew about proton number, we could tell the atomic weight of the elements, and so initially the periodic tables were ordered in increasing atomic weight. So from left to right, top to bottom, the elements were placed in increasing atomic weight. Mendeleev overcame the problem of elements being in the wrong groups by putting the elements together that had similar chemical and physical properties, similar properties. So he did this by leaving gaps. Mendeleev reasoned that by leaving gaps, the gaps could be for the elements that hadn't been discovered yet. So giving one reason, you could have said either of those two things. Mendeleev left gaps, or that Mendeleev put elements into groups with similar chemical properties. So 4.5 now, explain why neon is unreactive. Give the electronic structure of neon in your answer. So we're going to look at a couple of ideas now about electronic structure or electronic configuration and also reactivity. So first of all, can you think where we can get the total number of electrons that are in each neon atom? Well, you need to look at the periodic table. The proton number from the periodic table of neon is 10. How many electrons can fit into each shell? This is something that you just have to know off by heart. And for GCSE, you have to know that the maximum number of electrons that will fit in the first shell is 2. The maximum that will fit in the second shell is 8. The maximum that will fit in the third shell is also 8. And 2 in the fourth shell. Now the fourth shell can contain more than 2 electrons, but we don't need to go into that until we go beyond GCSE. So the order of filling of shells, the maximum number of electrons that can fit in the first, second, third and fourth shells are given there, 2, 8, 8, 2. Atoms tend to share or transfer of electrons to get a full outer shell, and transferring and sharing electrons, this is what happens to electrons when they are making chemical bonds. Atoms or ions with a full outer shell are stable, so atoms will tend to gain or transfer electrons to get a full outer shell. They will tend to do that to become more stable. Let's try and address the question now. There's a few gaps for you to fill in. There are how many electrons in each neon atom? The electronic structure or the electron configuration of a neon atom is, and neon atoms have a of. So see if you can fill out those gaps. So we said earlier that there are 10 protons in each neon atom. We get that from the proton number on the periodic table. Protons are positive, atoms are neutral, and the only negative subatomic particle is the electron. So if there are 10 protons in each neon atom, there must be 10 electrons. If we take a look next at the electronic structure, that would be 2 in the first shell and 8 in the second shell. So the electrons fill the shells until they move on to the next one. So 2 in the first shell, then we move on to the second shell, 8, and that gives us a total of 10 electrons. So there's our 2 electrons, 2 in the first shell, 8 in the second shell. So we can say that neon atoms have a full outer shell of electrons. So they are unreactive because they don't need to share or transfer electrons in order to gain a full outer shell. So that will get you the 2 marks. You could have also said there's a stable electron configuration or a stable electron arrangement. So neon has a stable electron configuration, or 2,8 is a stable electron configuration. So I try to add videos quite regularly. If you have any questions about the videos, let me know. If you have any suggestions, if you got any requests for particular questions or topics, again, I'll do my very best to help. Thanks for watching. There's the details about where we got this question from, and the format that we used for this question was black text, the question itself, blue text, the model answer, and red text is additional information and explanation. Once again, thanks for watching.